Today we're going to be learning about scientific notation. So scientific notation is used for very large and or very small numbers. And scientific notation is written as a times 10 to a power of n, where n is an integer and the value of a is greater than or equal to 1, but it's also less than 10. So here let's make a chart for the powers of 10. So here we have a trillion, which is our trillion, the ratio, which is 10 to the 12th power for a trillion. 1 billion, the ratio for it, which is 10 to the 9th power. 1 million, the ratio is 1 million over 1, and our power of 10 is 10 to the 6th. 100,000 is 100,000 divided by 1 for our ratio, which is just 10 to the 5th. 10,000 is 10 to the 4th. 1,000 is 10 to the 3rd. 100 is 10 squared, 10 is 10 to the 1st, and 1 is 10 to the 0 power. So if you notice here, this is telling us how many times we're multiplying 10. So here, we didn't multiply 10 at all, and that's why we equaled 1. Here we multiplied 10 once to get 10. 10 times 10 times 10 times 10, 6 times ends up being a million. So then if we work with the tenths, we have 1/10, which is really 1 divided by 10 as a ratio, which is 1 divided by 10 to the 1st power, so it's 10 to a negative 1st power. 100th is 1/100th as a ratio, which is 1 divided by 10 squared, so it's really 10 to a negative 2 power. So I'll give you a second, you can fill this in, pause the video, and create your table. Let's look at each of these and write each number in scientific notation. So remember, our value of a needs to be greater than or equal to 1, but less than 10. So right now, our a value is 55. So in order to get that to be greater than 1 or less than 10, we need our decimal to be between our two 5s. So that means we're now left with 5 and 5/10 times by 10. But since we moved our decimal, we need to then make sure we change our exponent. So right now, if I just took my 55 times by 10 means I'm moving my decimal 4 places. That means I'm going to end up with this number. So it is 550,000. So if I take my 5.5, I need to find out how many times I need to move my decimal, so I end up with this same value. So I need to move it 1, 2, 3, 4, 5 times in order to end up with 550,000. So it's going to be 5.5 times 10 to the 5th power. If we look at the second problem, 3 2/10 times by 10 to the 5th. 3 2/10 is greater than 1 but less than 10. So this is in scientific notation. For our second one, we have 9/10 times 10 to the negative 2. 9/10 is less than 1, so this is not in scientific notation. So we need to move our decimal so it's to the right. So then it means we're going to end up with 9.0 times 10. Let's figure out what our exponent's going to change to be. So if we kept it as our 9/10, we had to move our decimal 2 places to the left. So that means our number is 9 thousandths. So if we have our decimal at 9, and it's right here, we need to figure out, well, how many times do we move it so we end up with 9,000? So 1, 2, 3 times to end up with our 2 zeros. So this is going to be to the negative 3rd, and it's negative because we're working with a small number. So for our last one, we have 7 3/10 times by 10 to the negative 5th power. Well, 7 3/10 is greater than 1 and is also less than 10. So this is in scientific notation. So let's take and write these into scientific notation. So here, right now, our decimal is after all these zeros. So in order to end up with scientific notation, we have to move our decimal so that it ends up between this 9 and 0. So it's going to be greater than 1, but less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times it was moved. So when we moved it, it became 9.04. And we want to make sure we include all the numerical values that we see, and then once we have just zeros, we can leave out the zeros. Times by 10, So our power is going to be a 9, and it's going to be a positive 9, because when we look here, our number is a very large number. And when we are working with a large number, we're going to have a positive exponent. So in this one, we need to move our decimal place so it's on the other side of the 8. So in order to move it, we're moving it 2 places. So after we move it, we end up with 8.0, which is greater than or equal to 1, but it's also less than 10, times by 10 to the, well, we moved it 2 places, but since we're working with a small number, it's less than 1, it's a negative exponent. 9.3 million, well, 9.3, that number is greater than or equal to 1, but it's also less than 10, so we can use 9.3, and since it's to the millionth, remember million has a power of 10 to the 6th power. So this is 9.3 times 10 to the 6th power. Last one, right now our decimal is at the end of 22,300, so we need to make sure our A value is greater than or equal to 1 but less than 10, so that means we need to end up with our decimal between the two 2's. So 1, 2, 3, 4 times it was moved. So we have 2 and 23 hundredths times by 10. We moved it 1, 2, 3, 4 times. And since this is a large number, it's going to be a positive exponent. Let's write each number in standard notation. So here we have 5 with our decimal to the right, and it's a 2, positive 2, so that means we are getting larger, so we're going to move our decimal 2 places. So we are now looking at 500. Here we have 3, and our decimal is to the right. Since it's a negative 2, we're getting smaller, so we're going to move our decimal 2 places to the right, or to the left, sorry. So our standard notation is 3 hundredths. In this one, we move our decimal 3 places, and it's a positive, so we're getting larger, so we're going to move it 1, 2, 3 times. So we have 2,040. And this last one, we have 7 and 4 tenths, but we're moving the decimal 6 places to the right to get larger. So 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 7,400,000. Let's fill in our missing values. So we're looking at selected masses, and these are in kilograms. So if we're looking at an elephant, the scientific notation for the mass of an elephant is 5.4 times 10 to the 3rd power. So that means we are moving our decimal 3 places. So that means our elephant weighs 5,400 kilograms. An adult weighs 70 kilograms. So in scientific notation, we need to have our our decimal be greater than or equal to 1 but less than 10. So that means we need 7.0 times by, well, we moved our decimal 1 place, and since it's a large number, it's larger than 1, it's going to be a positive exponent. A dog weighs 10 kilograms, so we need to get our decimal. So it's greater than or equal to 1 but less than 10, so that means we have 1.0 times by 10. We moved it 1 decimal place, so it's going to be a positive 1. We have a golf ball that weighs 46 thousandths. So when we move our decimal, we have to move it 1, 2 places, so we end up with 4 and 6 tenths. We moved our decimal 2 places, but since it's a small number less than 1, it's going to be a negative 2. We have a paper clip, so if we have 5 and if our decimal is to the right, we're moving it 4 places to the left. So that means our paper clip weighs that. And last one, oxygen. We're moving our decimal so it's behind to the right of the 3, so we have 3.0 times by 10. How many times do we have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 times. And since this is a really small number, it's less than 1, it's going to be a negative exponent. So look at these last three. So we need to answer using each in scientific notation. So first let's do 8 times 3, which is 24, times by 10 to the 14th, but this is not written in scientific notation. We need to get our decimal, so it's moved between the 2 and the 4. So this is 2.4 times by 10 to the 15th power. When we multiply 6 times 5.3, we end up with 31 and 8 tenths times by 10 to the negative 4th. But this is not in scientific notation because it's greater than 10. So our decimal needs to move between our 3 and our 1. So that means we have 3 and 1800ths times by 10 to the, well, for this one, it's going to be 10 to the negative 3. And our last one, if we do 5 tenths times by 6.8, we have 3.4 times by 10 to the 5th. And since this is in scientific notation, we do not need to change anything.